Alright, I'm sorry guys, I'm not re-recording that video. It got cut off because I tapped on a different application. Alright, let me just pick up where I left off. So taking out the calculator, it's 9 EXP, oh, hang on, 9 EXP 9 times 3 EXP 6, and remember, don't put the negative sign in, never do that. I get 27,000. So this one is 27,000 newtons per coulomb. And let's say it's north, not up, just north. Okay. So how do we know it's north? Well, that's the blue vector, right? The blue one is attracted. Remember, I put a little positive charge in the blue box. It's going to be attracted to that -3 charge. Okay. So therefore, that's a north force. Okay. Now, on the other hand, it's going to be repelled from the 6 microcoulomb charge. So let's do that one next to it. E2 will equal KQ2 over R2 squared, like this. And so we need to figure out R2. R2 is going to be this distance here, okay? So that's a right angle triangle. So I'll write that over here. I'll just say that R2 squared equals, what is it? 1 squared, right? Plus 2.5 squared. I don't need to take the square root since it's squared in the formula anyway. Plus 2.5 squared, like this. So that's 7.25 meters, right? Okay. Square meters, pardon me. Yeah, I didn't take the square root. Okay, so like it's still squared. And maybe I'll just forget that and just write 7.25. Okay, so this is going to equal 9 times 10 to the 9 times 6 times 10 to the -6 divided by 7.25. Now I don't have to square it because I left it squared. Okay, so it's going to be 9 EXP 9 times 6 EXP 6 negative equals divided by 7.25, and I get 7,448.3. 7,000. That number right? 448.3, right? So this is equal to 7,448.3 Newton per coulomb, and here's the thing. I need to know what theta is. I'm just going to say that tan of theta is 2.5. I need theta. Well, actually, no. We'll just leave it. I don't really need it. I know that the hypotenuse is the square root of 7.25, right? So I won't need it, but when I do my components, I'll have to be careful. Okay. All right. So that red vector is definitely it's so many degrees, like west of south, whatever it is. Well, for us, we'll worry about the direction in a moment. All right, so I've got these two fields. How do I add them together? Well, components. All right, so first I'm going to pick directions to be positive. I'm going to say north and west. So north and west are positive, and I'm just adding these two vectors. That's all, no big deal. So my first one here, E1, is 27,000 north and 0 west. I won't write N for north. Okay. E2 is equal to 7,448.3. But then if you look at this red vector has two components associated with it. One in this direction. I'll use this color, one in that direction. Whoa, forget that. So one in this direction here like that, and the other one in this direction here like that. Okay, now so here's the deal. Now this one is going to go with cos of theta. That one is going to go with sine of theta. Okay, so my red vector I have to break into two components, and theta is going to be like defined in the triangle here. Okay, so coming back to this picture here, if you want, we can find theta if that's going to make you more comfortable. I was just going to use sine and cos, but if you want, you can find theta, because I know I'm going to confuse you with this. So first let me finish the table just by writing down the values. So the north component is going to be negative because it's south, for one thing. Okay, like look at my red vector is south. And then I'm going to go E2 times the cos of theta. Okay, and then here the west one, 7,448.3 sine of theta. Okay, so those are my two things. If you want to know what theta is, we'll just go tan of theta. If you look at my original triangle, tan of theta is 2.5 over 1. So I'll just take my calculator, 2.5 divided by 1. That's just 2.5, of course, second function. I get 68.2 degrees. So theta equals 68.2 degrees. So let's go ahead and just put negative 7,448.3 times the cos of 68.2. And then on this side, I have 7,448.3 times the sine of 68.2. All right, I assume you know what to do next, because we've done these things so much this year. What you do is, here I'll just put a little line here, find your total north, and your total is your total field, that's west. Okay, there's only one vector there that's west, so that's easy. And then the vector that's north, and then you proceed, I'm just going to write as usual for components. So you find the two components and you put them together with Pythagorean theorem and tan of theta equals small over big. Okay, and that's it. So I warned you it was a little strange, this how this works. Okay, electric fields, they're going to give you these two charges and give you an empty point in space and say what's the field right there at that point. Well, this is how you do it. So little three-body diagram, a little component method, no problem. Okay, so that's it for today. I'm sorry this got divided up into 2 videos. Now it's past my bedtime, but I wanted to get this done tonight and post it. So we'll talk maybe soon and have a little help session. I know you'll need it. Okay, everyone needs it in this unit. It's just because it's new kinds of problems that you've never done before. But in a way, we've been doing components. It's just a new type of vector. But it's still the same old component method. Plus you got to use a formula, but that's not too hard. All right, so have a good night. We'll talk to you soon.